Richard Feynman was one of the most brilliant and charismatic physicists of the 20th century, known for his deep insights into quantum mechanics, his revolutionary work in particle physics, and his extraordinary ability to communicate complex scientific ideas with simplicity and enthusiasm. Born on May 11, 1918, in Queens, New York, Feynman showed an early aptitude for mathematics and problem-solving, encouraged by his father, who instilled in him a love for scientific inquiry. He attended the Massachusetts Institute of Technology, MIT, where he quickly distinguished himself as an exceptional student, and later pursued his Ph.D. at Princeton under the guidance of John Archibald Wheeler. It was there that he first began developing his unique approach to quantum mechanics, laying the foundation for ideas that would later transform physics. During World War II, Feynman was recruited to work on the Manhattan Project, the top-secret U.S. effort to develop the atomic bomb. Stationed at Los Alamos, he contributed to theoretical calculations related to nuclear reactions and the behavior of explosive materials. Though he was a junior scientist compared to some of the towering figures of the project, his sharp mind and unconventional thinking made him stand out. He was known for his mischievous sense of humor, his ability to crack safes containing classified information, and his unorthodox approach to problem-solving, which often involved intuitive, visual reasoning rather than rigid formalism. After the war, Feynman took a teaching position at Cornell University, where he made some of his most significant contributions to physics. His most famous work was in quantum electrodynamics, QED, the theory that describes how light and matter interact at the quantum level. The existing formulations of QED at the time were plagued by infinities and inconsistencies, but Feynman developed a revolutionary new way to visualize quantum interactions using what are now called Feynman diagrams, simple pictorial representations that made calculations much more intuitive and manageable. His work, along with that of Julian Schwinger and Shinichiro Tomonaga, earned him the Nobel Prize in Physics in 1965, fundamentally changing the way physicists approached quantum field theory. Beyond his theoretical achievements, Feynman was an extraordinary teacher, famed for his engaging lectures and ability to break down intricate concepts into clear, understandable explanations. His lectures at Caltech, compiled in the Feynman Lectures on Physics, remain some of the most influential physics texts ever written, inspiring generations of students and scientists. He had a deep curiosity about everything, from the fundamental nature of reality to the physics of everyday phenomena, and he delighted in exploring seemingly simple questions with profound implications. His interests extended beyond pure physics. He was fascinated by biology, computing, and even art, famously teaching himself to paint and becoming an accomplished bongo player. In 1986, Feynman gained widespread public recognition for his role in the investigation of the Challenger disaster. As part of the Presidential Commission examining the explosion of the Space Shuttle, he famously demonstrated the failure of the O-ring seals by dropping a piece of rubber in ice water, showing how cold temperatures had caused the material to lose its flexibility, leading to the disaster. His straightforward, no-nonsense approach and his insistence on exposing the truth, even in the face of bureaucratic resistance, cemented his reputation as a scientist of integrity and intellectual rigor. Despite his many accomplishments, Feynman never lost his childlike sense of wonder and his joy in discovery. He rejected prestige and formality, preferring to engage with the world through curiosity and playfulness rather than through titles and honors. Even as he battled cancer in his later years, he remained deeply engaged in physics and in the process of learning itself. Richard Feynman passed away on February 15, 1988, but his legacy endures, not just in his scientific contributions, but in the way he inspired countless people to approach the world with curiosity, creativity, and a willingness to question everything.